Okay, Assalamualaikum and good morning everyone. My name is Danishyahya ZAKARIA, a final student from Department of Civil Engineering, Faculty of Engineering UPM. So today's presentation is about my final year project, which is coastal flood risk modeling for assessment of property level adaptation. So this study is about the flood risk assessment based on sea level data that affecting the flood event at the study area, which is Taman Teluk Gurun Indah, Port Klang, that recently happened. Besides that, this study also investigating the effectiveness of the property level adaptation or PLA as flood protection. So the term of PLA in the study is referring to the flood barrier that can be implemented on the residential property to avoid the ingression of water into the house during the flooding event. So there are three objectives altogether. First is to determine the flood hazard, which is the sea level, and exposure, which is the number of affected house at the study area. Second is to estimate the flood risk under different scenarios of implementation of PLA. And lastly is to analyze the economic benefits and return of PLA. As mentioned earlier, the study area is at Taman Teluk Gurun Indah, Port Klang, an urbanized residential area that involves 1,047 terrace house. The determination of the study area is based on the Malaysia Annual Flood Report, where the study location have been affected by several flooding events during September and October of 2020. The type of flood happened on the area is classified as coastal flood since the study location is near to the shoreline. So let us move to the methodology. The methodology or procedure in the study is divided into three phases. First one is data collection, pre-processing activity, and final output. The data collection starting with the determination of study area continue with the data acquisition based on the study area. The data required in the study is as shown here. It is consisting of study data, damage factor, digital elevation model or DEM, and present market value of PLA. The tidal data that have been used is from tide table provided by the National Hydrographic Center, specifically at Port Klang Station. The damage factor is extracted from the flood damage assessment report by Department of Irrigation and Drainage. Meanwhile, the DM for the study location was obtained from JUPEM, Department of Survey and Mapping Malaysia, which is ISFA, that have 12.5 meter resolution. The present market value of PLA consists of the cost of flood barrier per unit from local gate flood gate manufacturer. Then all this data will be processed and analyzed to produce estimated data such as probability distribution function, PDF, and flood risk. After that, this process data will be implemented in cost-benefit analysis to determine the effectiveness of PLA in terms of net present value, NPV, and present and benefit cost ratio, BCR, in order to determine the most favorable PLA to be implemented on the area. So the application of PLA on the study area based on the elevation of houses is shown in this diagram and the table below. The cost of PLA is shown in this table is based on present market that ranging from 300 ringgit to 1,000 ringgit. However, the type D PLA is an additional control due to certain uncertainty in the flood protection. So for the result, the stage damage relationship that's shown here shows the comparison of the reduction of damage upon the different scenarios in potential of PLA, where option 4 shows the highest reduction among the different scenario of implementation. Stage damage relationship is developed to show the damage in inventory form due to increment of flood stages or water level before and after the PLA implementation. Then reduction benefit of PLA also can be measured as it's illustrated from probability damage curve, where the option 4 again have 100% damage reduction with zero annual expected damage or EAD that is calculated throughout 2 to 1,000 years of waiting period. So the effectiveness of PLA will be measured in economical terms, which is net present value and benefit cost ratio. From the cost benefit analysis, the highest NPV among the type of PLA is shown here, where all the value is positive value that indicates positive return and profitable. However, the term profitable is not a direct income, but the long-term benefit with the money that can be saved when applying the flood protection. Then the highest BCR is dominated by option 1A, while the lowest is option 1 or is option 4D, which the PLA is considered as cost effective if BCR then more than 5, then cost beneficial when the BCR is greater than 1, but less than 5. So from the analysis, the most cost beneficial PLA is option 4C, as it is covering all the houses located at 2 to 3 meter above datum that might be affected by the flood depth up to 3 meter above datum. So in conclusion, all the aim and objective in the study, which are to determine the hazard, exposure, risks, and economic benefit of PLA has been achieved. Then all the option of PLA intervention can reduce the risk of flood damage, which is proven by the high and positive value of NPV and BCR from the cost-benefit analysis. So the outcome of the study may be utilized in financial planning of micro-scale flood mitigation project, where additional parameters and uncertainty need to be considered to increase the accuracy of the data. So that's all from me. Thank you.